Factors that determine the performance of a manufactured products, other than the mechanical and the physical properties, include the dimensions and the tolerances. The dimension can be defined as a numerical value expressed in appropriate units of measure and indicated on the drawings and in other documents along with the lines, symbols, and notes to define the size or the geometric characteristics or both of a part. The tolerance is the difference between the maximum and the minimum limits, and also this can be defined as the total amount of the specific dimension is permitted to vary. And it's used to define the limits of the allowed variation. Can be classified into three types, which are the bilateral, the unilateral, and the limit dimensions. Some manufacturing processes are inherently more accurate than the others. Most machining processes are quite accurate and capable of tolerances of plus minus 0.05 millimeters or even better. Manufacturing tolerances is necessary when operating conditions can be unpredictable and extreme, or if expected to perform for decades on the end without much deteriorations. The physical parts themselves might change shape naturally. For example, the railroad tracks have a thermal expansion due to the high summer temperature factored into their design. So why the tolerances are important in manufacturing? Simply because they improve the fit and the functionality of the parts. Also, they improve the look of the end products. You can account for a reasonable amount of the error. Also, more cost-effective manufacturing can be achieved. The product reputation will be increasing, and the tolerances will reduce the manufacturing ambiguity and complexity. The measurement provides a numerical value of the quantity of interest within a certain limits of accuracy and precision. The accuracy is the degree to which the measured value agrees with the true value of the quantity of interest, while the precision is the degree of the repeatability in the measurement process. The good precisions means that the random errors in the measurement procedure are going to be minimized. With the measurement accuracy range between 1 mm to 1 in 1000 of the millimeter, the conventional measurement instruments and gauges can be classified into first, the precision gauge block, second, the measuring instruments for the linear dimensions, third, the comparative instruments, fourth, the fixed gauge, and finally, the angular measurements. For more precision measurements, with the accuracy of more than 1 over 1000 of the millimeters, more advanced measurement instruments are used, like the CMM probe machine and the CMM 3D machine measurements, and the 3D scanning and the microscopic inspection.